Hello guys, welcome to our channel. Today's topics of the interesting mathematics blocks is the binomial expansion, and the today's introduction is to the Pascal's triangle. So this section of the binomial expansion topic will be divided into big two parts. So here this first part is just an explanation of how to get an intuition to the binomial expansion. So after that will be the general formula of how to handle with the combination formulas, and we will learn how to get the a plus b to the power of n. Okay, so here our goal is to investigate and achieve this a plus b to the power of n. So but for now we are dealing with the intuition of the binomial expansion. So what is a binomial expansion? And here the Pascal's triangles come into a picture, come into a mind to understand the concept of the binomial expansion. So here I have a triangle, okay, already drawn. So what does the triangle means? So if we notice that the up, left, and right side, they all have all ones, yeah, 1 1 1, they already have ones. So what about the other numbers? So here the plus is the 1 plus 1. 1 plus 1 is equal to 2. Okay, where 3 comes from 1 plus 2, 3, 2 plus 1, 3, 3 plus 3, 6, 1 plus 3, 4, 3 plus 1, 2, and etc. So I hope that you got an intuition. So we will continue our lesson. So here what we have our problem with the understanding of these numbers. So here our question is, okay, we know how to compute these numbers, and we know that the 2 is the sum of the 1 plus 1, but what does that mean to have this number? So here I'm going to explain the one of the more things. So here our goal is to achieve the a plus b to the power of n. So let me just put in numbers in the columns of our triangle. So here existing respective column for the first should be zeros column. So for the next one, the column should be first, second column, and the third, and 4, 5, and up to nth column. Great. So what does that mean? That we have at the first column we have 0. So here it's nothing but it is equal to a plus b to the power of the 0. So I hope that every student or high school student pupils know that the every expression a plus b or a to the power of 0 should be equal to 1. So this one comes from this a plus b to the power of 0. So what about the next one? So the next one is a plus b should be a plus b to the power of 1, because we have the first row. So a plus b to the power of 1 is just a plus b. So what about the 1 and 1 here? So 1 1 here is just the coefficients of the a, 1 times a plus 1 times b. So here we have 1 and 1 as the coefficients of our a and b. So sounds great. And the next one is a plus b squared. So for now, just since we know from the 7th grade or 6th grade that this is the formula of squares, so it is a squared plus 2ab plus b squared So just for now, let's assume that we know this formula, and I'm trying to get an intuition of how these numbers would be helpful to us to solve the binomial expansion. So here our coefficients of the a squared plus 2ab plus b squared is 1, 2, and 1. So exactly the coefficients are matching. So okay, if we continue, so this is the third order, should be a plus b to the power of 3 cube. So again, let's assume that we know the formula. So this should be a cube plus 3a squared b plus 3ab squared plus b cube. Great job. So again, the coefficients are 1, 3, 3, 1, 1, 3, 3, 1. Oh, crazy, yeah? How we just understand how we get these numbers and why the Pascal's triangles coefficients are important in order to expand our binomial expressions. So here we end up with the expanding and trying to deliver and derive these formulas by the Pascal's triangle and getting an intuition of the binomial expansion. So here, guys, for now we need to understand that the every for example here I will write, for example, a plus b. For example, if we get 2 squared, so what I'm trying to deliver for you that the a and b doesn't matter the order. Let's assume that the first we have a, so the first we need to take the highest power of a. So highest power is square, so a square, and we need to multiply this to the b to the least power. So least power here is 0 because b0 is 1, and times a squared would give us a squared. Okay, plus, okay, what is the next coefficient from our Pascal's triangle is 2. So let's just put 2 times, so up to here our coefficient would be decreased. Our coefficient of a, which was a squared, would be decreased to 1 coefficient, so it will 1 degree, decrease it, minus 1 should be a of 1, times b is increasing by 1. Okay, so should be b1 plus, what is the next coefficient from our Pascal's triangle is 1. Okay, 1 will not down it right, so we're writing down our b, or not b, okay, don't confuse with the b. Let's talk about a. So a would again increase by 1, so it was a of power 1 decreased by minus 1, it will become a of 0. And what about b? B should increase by 1. It was b to the power of 1 plus 1 b squared. So noticing and knowing that the a to the 0 is equal to b to the 0, and both of them are equal to 1, we have our quadratic formula. So a plus b squared is equal to, okay, a squared plus 2ab plus b squared. Okay, great job, guys. We just right now we derived our quadratic formula so that we cannot confuse with the coefficients, because we can draw the triangle and obtain the right coefficients. So from right here we don't need to confuse with the combinations with the a squared, b0, a1, b1, a0, b2. It's just like the logical order of how the coefficients from the Pascal's triangle can be helpful to identify the correct factorizing and expanding of the a plus b to the power of any power, for example n. So let's talk about the a plus b cube. So for example, here I will put mark 1. Okay, a plus b cube. Great. Okay, the first thing, if we consider cube, let's see the third row. We have the coefficients 1, 3, 3 and 1. So the first coefficient is 1. Okay, I will not write the 1, just I will leave it. So as I said, in the squares computation, we need to first use the highest power of a, should be a's cube but not square. The square was in the previous, so here we have cube, a cube, and the b is with the least power. This is 0. Okay, plus what? Plus it should be increased to, b should be increased to 1 and a should be decreased to -1, but the coefficient is 3. So let me write 3 times, so a would be a squared because -1, and again b is 1 because +1 decreased by 1. Great. So and plus, what is the next coefficient? 3. So let's write 3 times, so from that point the a again would be decreased by a -1, so it should be a1, and b is b okay, b plus 1 should be b squared. Okay, plus the last coefficient is 1, so 1, okay, times a should be 0 because it will be decreased by -1, and times b has the highest value +1, which is the cube, so is equal to a cube, okay, plus 3a squared b plus 3ab squared plus b squared. Voila, guys, we have our right solution, because if we check out our answer would become, and it matches with the original. So here we have the original expansion, so this is our original expansion, and here is our result. So it matches, and congratulations, guys. Just now we are ready to go to the next, which we need to compute the 4th, 5th and 6th power of a plus b, and after that we will consider the general formula of binomial expansion, which will be talked about later using the combinatorics, combination, the formulas, and the would be helpful to your high school knowledge. So don't forget to subscribe to our channel if you like this video. So don't forget to subscribe, and let me know in the comments what was wrong, what was helpful, and what was not. And if you like this format, please vote here and let me know, that I will be happy to answer your questions. So goodbye, guys.